Okay, so last stream was 9 days ago. I'm sorry for this. Had to take a bit of a break because of other reasons. But I'm not giving up. I'm coming back at this problem. I'm trying to figure out where I left last time, but I think I almost need a recap video. That's why I'm doing this one, which is probably going to be a little more just like a refreshing. Because to be honest, after letting the whole thing sit for a while, I do have the feeling that I don't have enough. Like, I obviously need to guide. I need to find a way to guide the AI or Grok to find the blocks, right? Because eventually, what we want to do is get and be able to break down the problem enough so that Grok doesn't get lost. Grok makes mistakes when I ask it. So, first things first. Um, what I was doing is like, hey, so I was helping Grok step by step define the different um, groups, and I think that was good enough. So I'm gonna try to do the same again. We're gonna repeat these right now. So grok.com fresh chat, and we're going and we're just basically gonna copy these. So let it define this group. This is actually very good. I like the fact that I can just, okay, I can kind of skim to the prompt. Grok you. I think that is actually super helpful. I hadn't seen that before. I think it's a new feature. So we're gonna copy these. Gonna use quick answers. For some reason, it seems like not thinking gets me a better answer. Concrete description. So one way to realize this is a group of 3 by 3 upper triangular matrices over the field F3 with matrix multiplication modulo 3. This group has 27. Essentially, yeah, a group presentation is essentially, it's, yeah. Key properties, intuition, yeah. As a non-abelian group that is as close to abelian as possible while still having a non-trivial center and commutators. It's like a 3-group version of Heisenberg group, but with all non-central elements having order 3, making it distinct from which is element order 9. Yeah, exactly. That is all right. We've got so this is something where I'm fine. Now define. Now let's define D, right? We're here. Define C3. So these seems to, that's my current approach right now. My current approach is I'm trying to find at what level is Grok able to just run by itself and not make mistakes, right? There's obviously one step where it's failing, which is once I have all these, it seems to fail at the task of looking for blocks. All right, so we have now basically C2 squared. Exactly. Okay. So now we define C3. And the reason we're doing this is because we now want to do, so we're like, if you notice, we're breaking, what we're doing is we're breaking these problem into pieces. So we're defining S, we're defining D, then we jump off here and we define C3, right? And we're asking, we're going to ask it to find a non-trivial action of C3 on D, because this would then is supposed to induce the action of S on D to define G, right? So we're actually we're doing it this way. So so we've got C3. All right. Now give me the only non-trivial action from C3 on D. So we're like literally going step by step. That's, I mean, that is, you know, this is already a relatively complicated step, right? Because you have to find the actions. So, and it's kind of like understand the groups. C3 we have defined, D is already defined. So homomorphism from C3 to D, exactly. Compute the orthomorphisms of D. I don't know if it's thinking too much, but to make the action concrete, we need to translate the permutation in S3 to an automorphism of D. The 3 cycle in S3 permutes these elements x, y, y, x, y, x, y, x is fixed. So the action of C3 on D is for G equals A. The action G, D, okay. X, so X maps to Y, Y maps to XY, XY maps to X, and 1 maps to 1. Exactly. So it's like a permutation. Permutes the non-identity elements, and I think that is correct. Step 7, connection to S. Final answer. The only non-trivial action of C3. Okay, so we've got the action defined. All right. Now what we need to do is we need to so we have this action, and now we need to define the product G, the semi-product G, which is D R times S, and the action is going to be exactly the way that this worked last time was for me to just say now C3 is a subgroup of S, correct? So we want to calculate now sorry, here. Okay, maybe I hope that hasn't I didn't want to prove it. I didn't want to approve, but all right, maybe that actually helps. So you see, we're kind of, I think one of the things that I think can be really what I'm doing is context engineering, right? I'm trying to engineer a context into the conversation that actually makes it easy for the model to then solve the actual problem. Now we're trying. I want to calculate. I want to build a group that is a semi-product of D over S, like these, concretely. A group G. The action. So, in order to define the operation, we'll need the action of S over D. But I wanna use the action of C3 over D as basis and just basically extend it to fit S. So basically, I wanna induce the action using the one you just found. Can you please calculate G for me? It is what it is. I mean, solving, and I think this is interesting, right? Because thinking models try to emulate human context engineering by making the model generate in between thinking, generate like generate text that is used as extra context. Somehow this feels like a bit disconnected still. Human context engineering currently feels better than thinking chains. Thinking models. So but it is these, right? I mean, that's all I'm doing. I'm actually just like these type of problems. Like it's literally Grok is not able to actually calculate the answer. Grok is not able to do this on its own. I mean, we can try. In the meantime, I'm gonna copy these. I'm gonna open another one, and we're gonna switch to expert. Maybe heavy does it. I don't pay 3,000. I don't have that, but maybe, you know, maybe expert. Maybe it's gotten better. So let's run this again in the meantime. For some reason it went with that. Maybe let me switch to quick, because I have the feeling it thinks better, because essentially for context engineering you do not want thinking models. For context engineering, do not use thinking models if you are just doing context engineering. I think that is something that I can say it's true, because that's the point is you don't want them to get like you want them to be running very isolated steps. You know what I mean? So if we're okay, so let's construct the group G, recap the groups in the known action, blah 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 blah. Step goal and approach. Okay, so this is actually nice. Oh wow, wait a second, is it? Okay, so this is good. I mean, I know that that's not these. Where? Let me go to the. Okay, verification. This is good. The operation. This is good. This makes sense. Artifact and group definition. Group definitions. Actions of S and D. Group G. Properties. Structure G is non-abelian as the action. Yes, it includes normal group, normal set group D times. Okay, let's close this for a second. So we've generated a file. Show inline. That's all good. Now the action ensures that matching this action when restricted to as a semi-direct product is order 108. Well defined, checking the homomorphism. Yes. Can you please give me a concrete example / instantiation of G? I wanted to think more about G, maybe kind of generate an example, right? And where we should use quick responses. We should force it to be fast. In the meantime, it's still thinking for this one. Because remember, now we are getting at the point that now we're getting at the tough part, right? Which is now we've got G, right? And now we have to tackle the actual question, which is how many blocks does KG have? K being a large enough field with characteristic 2. Okay. So, but now we're looking for G, examples of G, and the next thing is we need to look for representations of G against like over a field, right? Let's provide a concrete example or instantiation of the group G. Recap the groups in action. Concrete of S, automorphism, blah blah blah. Action as matrix multiplication. Elements of G. Artifact with concrete instantiation. Uses matrices for S, vectors for D, and a matrix for the action, making computations explicit. The action is consistent with the C3 action on ZS. Example products. How do I explicitly? Okay. Can I show in sidebar? The file seems, the artifact file, does the artifact, or can you, represent elements DS as matrices, combine D as the diagonal matrices over F2 and S. Okay, so okay, fine, but we have these now. All right, but I think it's good. I think we're on a good track. I have 2-3 more minutes, and I'm gonna have to stop, but then I'll continue. See if I can continue later today with these. This guy's still thinking. That just makes no sense, man. maybe it's just too much. But it's really, I think that's kind of a learning, right? So I have the feeling that this is what I'm doing really here is basically context engineering. Now, now the thing of this is to do context engineering, you need to kind of be able to peel that off yourself, right? And sort of validate the steps in between. Let's keep it out general field. Okay, so okay, all right, cool. So we've got this is the one we're looking at now. Cool. Now, all right. Now we want to build a group algebra, or now we want to study group representations. Now let's have group representations of G. On fields on the smallest possible field of characteristic 2. Can you give me a list of potential fields to use? That's the next step. All right. That's the next step. Yeah. I have the feeling that the stuff that I've learned in the past like 20 or so videos has pretty much solidified right now in terms of like the different aspects of everything else in here. And that feels like such a simple problem. Yet like it doesn't actually, Grok4 doesn't actually, I don't know why it seems stuck. Maybe there's just too much going on. Maybe I can't use it in parallel. But okay, so to study representation of group G, the field interesting to the possible fields are infinite fields. Okay, and when it does this, the possible fields are finite fields, since infinite fields like F2 are not small in a natural sense, and finite fields are typically used for finite groups like G. The finite fields of characteristic 2 are F2 to the power of n. The smallest field is F2 with element 0, 1, where 1 plus 1 equals 0. All the fields include F4, F8, and F16. The smallest possible field typically refers to the field with the smallest order. However, we need to ensure the field is suitable for representations of G, particularly considering that G has order 108 and S is a 3 group, which may impose constraints on the characteristic. A representation is a homomorphism where F is of G to GL. F is a characteristic 2 and F is a vertical matrix of F. Okay, so the characteristic of F should not divide G for non-trivial representations to be faithful, but characteristic 2 is fine for modular representations where the characteristic divides by order group. Elements of order 2 in G may act like the identity in some representations as G squared equals 1 implies. Okay, so infinite potential fields. Elements is the smallest possible field. May have simple representation due to structure over F2, the field for elements, where the cube root of unity. Pro is the smallest field, natural 4D is the constant group requires elements of order 3. Yeah, so F4. That might be the 3 group S requires elements of order 3, right? So we cannot really instantiate these on F2. That's probably what it's saying. Is it? It's not a million. Better suited for S. Okay, but F2 still could work. This is the smallest field, so we would go with F2 first. Next steps. If you want to proceed with starting representation of G over F2, I can compute specific representations, true, reducible, faithful, analyze expression table. Explore the G. Yeah, exactly. Thank you. I mean, that makes sense. Where are you gone? Exactly. So, okay, so, oh, look at these. Oh, that's nice. Add to chat. Add to chat. Okay. Compute resistor. Yeah, let's do that. Okay, what happens if I do these? Okay, it just adds it like these. Interesting. Let's just do these. And yeah, I think I have to go, guys. Sorry.